On to finding the length of an arc. Remember I told you earlier that circumference is the length all the way around the circle. So does it make sense that the length of an arc would just be a fraction of that circumference? Two different ways that you can think about this, okay? You can think about this as this is a fraction of the circumference. So you find the circumference and then take a fraction of it, and that fraction would be what part of the circle your arc is over the whole 360. So it would be arc measure you would take arc measure over 360 and multiply that by the circumference. You could think of it that way, that arc length is just a fraction of the circumference. Or you could think of it along the lines of a proportion, where the arc measure is part of the whole 360 and the arc length is part of the whole circumference. So that proportion would look like this. Arc measure over 360 equal to arc length over circumference. You know how your brain works best. I'll do one way and the other a different way. Okay, so problem 4, part A, I'll do the red way. So I'm trying to find arc CD. What is the measure of arc CD? 90. And what fraction is that 90 of the 360? 1/4. Okay, so let's make sure that I'm showing all of my steps. I'm taking 90 over 360 and reducing that and getting 1/4. And then I take that 1/4 times the circumference. Well, this time they've given me the diameter, so finding the circumference is easiest by doing pi times diameter. So my arc length is just 9 pi over 4. And let's leave our answers in terms of pi. Be ready, however, for your notes to ask it of you either way.
How did you get the 9 times 4?
Okay. Were you with me here? Were you with me in finding the circumference? Okay? Remember, you're just taking that fraction and multiplying it by the circumference. Remember how you multiply fractions: straight across the top, straight across the bottom. 1 times 9 pi, 9 pi. 4 times 1/4. That's it. Okay, as I said, let's do part B the other way so that you can judge for yourself which method makes the most sense to you, which method are you more likely to keep in your brain because it's not on the reference sheet. And I can almost guarantee you'll have either an arc length problem on the EOC or you'll have a sector area problem. We'll talk about that tomorrow, but it's the same principle. Okay? So you have to make some sense of it and be able to translate it for that EOC, because I can almost guarantee you'll see something like it there. All right? So, arc STR. What is the measure of arc STR? Look at it. What's the measure of arc STR? It's 260. Good, good. So 260 over 360 equals the arc length that I'm trying to find, which is x, over my circumference, which is 8 pi. Before I go any further, if I've lost you somewhere, you don't know why I put something where I put it, yes ma'am. Notice what arc, I made this mistake yesterday. Notice what arc they're talking about. They're talking about this arc. So you would do 360 minus the 100 they gave you.
Do you have to take the pi off that? Or do you just do it?
When you're, excellent question. When you're doing your cross multiplying calculations, I would say leave the pi out and then just tack it on at the end. Yes, sir? Formula for circumference is 2 pi r. Okay? So before you cross multiply, however, look at these numbers. These are big, and they're reduced. So if you can reduce a fraction, you probably want to, just to make your life a little bit easier. So in my scientific calculator, I enter that 260 over 360 as a fraction, and my calculator reduces it for me. It's 13 over 18 equal to x over 8 pi. And that's just a little bit nicer to look at in my cross multiplying. Say that again? Now we cross multiply, yes. So we have 18x equal to 13 times 8, which is 104 pi. And eyes up, please, because some of you are still not quite familiar with how to do this in your calculator. What's the next step in my equation solving here? Divide both sides by 18. But if you take that 104 and divide it by 18, is it nice and pretty? I don't think so. All right, so instead of taking in your calculator and dividing 104 by 18, in your scientific calculator that you should have by now, take that 104 over 18. Type it in as a fraction. Okay, and your calculator spits back a mixed fraction. You don't want a mixed fraction, you want an improper fraction. Your calculator will do that for you as well. You go shift button, second button, whatever the button is that brings up your second functions, and then your fraction button, and it gives us a nice, pretty 52 pi over 9. Pause for the your turn below. So, if I am finding, ladies and gentlemen, the area of a sector, which is, in plain old teenage speak, you might describe the sector of a circle as a slice of the pie, a slice of the pizza. You're finding a slice of the area. As I said yesterday, today's lesson, gentlemen and ladies, today's lesson correlates very closely to yesterday's lesson. In yesterday's lesson, we talked about how arc length was a fraction of the circumference. By the same token, the area of a sector of a circle is a fraction of the area of the whole circle. Once again, just like in yesterday's lesson, you can approach these problems two different ways. You can figure out what fraction of the circle you're interested in and multiply that fraction by the whole area, or treat it as a proportion. Okay? So let's do this problem thinking about it along the lines of a fraction. You're taking a fraction of the area. Well, let's find the whole area first. What is the area of the circle? What is the area of the circle in problem 2? Well, remember, it's pi r squared. Do I know the radius? Yeah, so square it. So I have 81 pi is the area of my whole circle. What fraction of this circle am I interested in?
104.
Hold on, let me backtrack. How did I get? Are we good? Okay. So I'm trying to find the area of this sector. That's the piece of the pie I'm interested in. What fraction of the circle is that? It's 84 over 360. And by all means, you have scientific calculators, use them. Let's reduce this fraction. I get 7 over 30. Remember, if you enter a fraction into your calculator and hit equals, your calculator will reduce the fraction for you. Okay, so what I'm doing is taking 7/30ths of 81 pi. Remember how you multiply fractions. Straight across the top and straight across the bottom.
mean like 7 over 30 times 81 over 9, and then just
Absolutely. Which gives us 189 over 10 pi. Square millimeters.
Oh, Clouse, what are you doing?
You divide by 3.
In your scientific calculator, I reduced the 7/30ths back here, remember. You've got the 7 over 30. Okay, take 7/30ths in your calculator and multiply it by 81. Calculator does the hard thinking for you. But
Oh,
How do you do this?
remember how to change that mixed fraction in your calculator back to an improper one.
there's the second button.
Yes.
I did it.
Good on this screen. And if you were doing this as a proportion, what you would have is 7 over 30. Here, let me show you. You would have 7 over 30 equal to x over 81 pi. You get the same answer in the end. Okay? Your turn below. All right, so thought process. That is a segment of a circle. Okay, there is a triangle in that figure, but our final answer is not the area of the triangle, but is the area of the triangle necessary? Yes, of course it is. So, any thoughts on a strategy for how we're going to find the area of that funky little shape there? Isa?
I don't have to judge it, but I know 90 is 1/4 of 360.
Okay. So the strategy would start by finding the area of this sector. And once I find the area of that sector, find the area of the triangle next, and then subtract. Okay? So, step by step. Ladies, waiting please. Let's focus. Okay, so Isa made an excellent observation. 90 is 1/4 of 360, so I know that the area of my sector will be 1/4 of the area of the circle. How will I find the area of the circle?
Is it 90 times the 2?
Hold on, the area of the circle.
Squared, so 49 times 9.
Right, remember, pi r squared is the area of the circle. Don't forget what you already know. Don't complicate things.
So how did you get 49?
7 squared, tack on the pi. Okay, so the area of the sector is 49 pi over 4. Ladies, you're right?
I can't.
Okay, the next step is to find the area of the triangle. What's the formula for the area of a triangle?
1/2 base times
1/2 base times height. What are the base and height in this triangle? They're both 7. How do you know that? Fantastic question. I'd love to answer it as soon as the little murmurings stop, please. Okay, remember, the height of a triangle starts from a vertex and is perpendicular to the base. This is a 90-degree angle, gentlemen and ladies. Do we see that this segment could be the height and this would be the base? Base and height are perpendicular. Okay, so I have 1/2 times 7 times 7, which is 49 over 2. You could, of course, simplify that to 24.5 if it makes your heart happy. Because in the end, what you're doing in order to find your bottom line answer is, in your calculator, the area of the segment is 49 pi over 4 minus 24.5. It's just keystrokes. You guys are looking at it like it's crazy stuff. Okay, it's a little bit crazy stuff, but it's just typing stuff in your calculator.
Isn't that what just math is?
Getting philosophical, are we?
Actually, no, it's not. In geometry,
But we're all done with them now.
it's supposed to be that.
No, you should not get a negative area. Make sure that you're subtracting in the correct order.
Oh, you have to do it.
You get approximately 14
Yeah, I got it.
square inches. And